end user, creating a better user experience for them that is organized around what they want instead of organized around the different government institutions, that can have services based on the most up-to-date data and regulations. And as it was already explained, the regulations can change quite fast. So the technology should also adapt fast and based on touch points of the choice of the end user themselves. And you have many different ways of interacting with the government. Think about general web portal, a chat interface, a voice interface. These kind of interfaces still need to be supported in the future. On the other hand, you have the application owner that always has to change the code whenever the regulations change. That should be solved in a way so that he can use its own regulations of its own governments, but of course also from the others if he has to include them. It should also be able to maintain his application with a low cost, and preferably if things can go automatically, that would be great. Because what we see often is when an application comes online, it's working fairly well, but afterwards it's the quality degrades while people are using it. So you could learn something from their use. So our dream was, couldn't we improve the user interface automatically based on the user behavior of the people who are visiting the application? And of course, also the policymaker. He has written a lot of books with regulations, but wouldn't it be easy for him that he could also make it easily available for machines to read it? And wouldn't it be easy for him that he could build his regulations based on top of the others, and also maybe reason whether his regulation is not contradictory with some others. So that was our dream, and we tried to convince IMEC and Vlaio that we could come up with a solution. To be really honest, they didn't believe it in the beginning, and maybe also for us it was kind of a big step forward, because the complexity of this problem needs a variety of different expertises. So in the beginning, you need to start mixing NLP with creating better user experiences and so on and so forth. So we had difficulties in understanding each other, but nevertheless, we convinced IMEC and Vlaio, for which we are still very thankful for. And we sat together then afterwards a lot to come up with a solution, with a technical solution that would make it feasible to fulfill this dream. And then we refined it in 4 building blocks. And Raf already mentioned them before, but I will go through them in a bit more detail. And then afterwards, you will see some demonstrators based on the FAST technology. So the 4 building blocks that we need to create this dream is, on one hand, solid, mature, linked data formats to model the live events that we want to solve for, or want to support for the end users. And a live event, that's a moment in the life of the user in which he needs to interact with the government. Think about moving, when you're moving from one house to the other. Think about renovating, which was already mentioned by Sander, and so on and so forth. So we wanted to have a decent open linked data formats to model these live events. And that's the first building block. The second one was the journey composer. So once you have this live event modeled in data formats, then you can, based on that, generate a customer journey that is as simple as possible and as personalized as possible. Because when I'm moving and when I'm 70 and I have a handicap, then I might get a permit to park my car on a handicapped space. But when you're 43 and not handicapped, you don't have to ask these people because they don't match the criteria. Yeah. So in this way, based on regulations and on criteria and on the evidence that we try to collect from the criteria, we can personalize these journeys. Once we have the live event, and then we also know how it fits to the personal context of a person, then we can build a UI, a user interface out of it, so that he can interact with the touch point of his choice. As said, a chatbot, a website, these kind of things can be generated. But of course, then that chatbot or that a website is available, then people start using it. So the fourth building block is, what about improving the websites and the chatbots and so on and so forth by interpreting the behavior of people on that website? That was a fourth building block. And we did that. We have built a demonstrator for that based on the live event moving. It's a big one. So we didn't solve it completely, because you can be a non-European, you can be a European, you can be a Belgian person, you can moving from one place to the other, you can move within your own town, you can also move to another town. All these kind of things have other regulations. But we took parts out of it, and that's the demonstrator that we started working on, and which Sander will afterwards show you. And in the first step, we created then that Oslo steps, in which we describe on one hand the steps that you have to take to fulfill this live event, the status of the user, what do we know about this user and what do we need to know about this user, and its goal. In this case, the goal is moving. So that's what we have been working on. And when you look at Oslo Steps, it's a linked data format where you can define the requirements. What do you need from the person as inputs? What will it produce? And what is the result that will come out of it? And also even what is the weight? And we'll come back to that later. That means how, amongst others, how difficult it is for excuse me, the end user to fulfill this step. As we already mentioned, it's not that easy for people to write this kind of format. So we started looking at a way to do that in an easier format. And what could be easier than the language and the visualization that we use to learn our kids how to code? So we started looking at Scratch to edit this. I'm not going to talk about that a lot, because Sander will show you how easy it is to create an Oslo step definition based on the Scratch interface that we have built. So once we have then modeled the moving live event, then we can start using it in the journey composer. And it takes whatever was defined in the journey composer and starts to create a journey that is fit for the specific end user. Imagine, for instance, you have Bob, he is 77 and he wants to move to Ghent. Then he needs to take some steps, and of course this is simplified in order to make clear to the town that he is leaving from, and to the town that he is going to, and to the Rijksregister that he is doing this event. So he needs to provide his Rijksregister number, he needs to provide his waste info, and so on and so forth, and of course also his name and his phone number. But that name and phone number, that can be maybe come from an authentic source that is already there. So we of course took into account the once only principle, and we said, okay, we cannot ask twice what we would already could know. And also all these in this live event, we need to communicate to different governments. When these governments ask duplicated data, of course, we can remove these duplicates. That's what we do in this journey, but we also create alternatives because maybe it's easier for users to go via It's Me or via the EID authentication or without an authentication. Different alternatives are created by the Journey Composer, and in that way we make sure that we can find the right one. This journey is then interpreted by a journey UI generator in which different processes are brought together in one live event and then again disseminated to different environments. For instance, the moving environment the moving live event can be supported by the website of Cellzate, the chatbot by Flanders, or the voice UI, let's say, from the federal government. And you already see part of the demonstrator here. Which is the chatbot that is using the Journey Composer as input. We already said once that UI is available, if the application could be smart enough to automatically improve its user experience based on the user behavior. What is needed there? First of all, we need different journeys instead of one, but we already can check the box there because we have the Journey Composer. I already told you that we can do that there. We also need to have different candidate UIs, which is possible from the UI generator. And then it's easy. Then we just need to make sure that we can measure everything from the user behavior and its satisfaction. We'll make sure that we have, let's say, an A/B testing experiment engine on steroids so that we can start finding out which component, which journey, which touch point is working the best. And this not only for all people, but also for specific people, let's say, for instance, people that are older or younger or male or female or whatever, people from abroad, people from Belgium, all these different segments could be tracked. That's the basic idea, and that's injected automatically in the systems so that it's constantly improving itself. That's the basic idea in that. So, okay, in brief, this is what FAST is about. Now we're gonna show it a little bit. First of all, Sander will start talking about the moving demonstrator that was built in the FAST project. And then secondly, Tim will talk about a proof of concept that we already did for the federal government in the context of single digital gateway.
All right, thank you, David. So everyone should be able to see my screen. Thank you, David, for the introduction. I will be showing most of what David has explained in his slides. Hopefully everything makes sense and you will recognize most of what David told in what I will be showing. And let me get started with the Scratch editor. So as mentioned before, Scratch is actually developed, or it's actually an open source framework or tool from MIT, which was originally meant to learn kids to program. And since it's open source, we decided to reuse it to visualize those live events, those user journeys. What I prepared here is the moving live event. So that's what you see here. And that moving event is built upon a few different building blocks. I'm going to discuss it briefly, not into too much detail, because that's actually part of the Oslo steps, which is discussed in track 1. So if you're interested, you can always have a look at track 1 afterwards. Thanks to the recordings. So very briefly, first of all, the green items that are the different Oslo steps. So every green block, let's say the citizen's first name, last name, and so on, that are individual steps, so individual inputs that we need from a user, individual inputs or actions or so on. It can be an input for first name and last name. It can be an action being you have to log on, for example, and so on. Those steps are combined into different states, and each state is actually a sub-goal in order to reach the bigger goal being I want to move from one city to another and I want to comply with all regulation. Those sub-goals or states are these different blocks that you see here, which is, for example, I need to provide some name, I need to provide some basic contact information, some moving data, and so on. That are different sub-goals that I can reach individually. Third part is on the right side, that are the actual shapes. So each step, let's say a first name, a last name, a citizen's national number, is first of all linked to the Oslo ontology. So in terms of interoperability, it is linked to parts of that ontology. A first name is a given name of inwoner. National number is registratie as part of inwoner, and so on. What you see next is also parts of validation. We can add data types to it. We can add additional requirements. For example, first name, last name has a requirement minimum 1, maximum 1, which actually means we need exactly one name, so it's a mandatory field. For the national number, we can add a regular expression stating the exact format that a national number needs to be. So this is the complete live event, as already mentioned. This live event is then used by the user journey composer to create actually a personal journey out of this generic journey. So based on your personal situation, based on the data we already know from you, the user journey composer will create a personal journey out of this. And that personal journey can be used by us in order to create different user interfaces. I'll be showing you two different interfaces today. First of all, the web forms interface. Secondly, the chatbot interface. But it's a generic setup, so as already mentioned, other interfaces could be created as well, for example, a voice interface. Those interfaces are created by the UI generator by combining a few items. First of all, of course, we integrate with the API of the user journey composer in order to get the next steps for that user. So we know which steps do we need to use to reach the next sub-goal in that user's personal journey. Secondly, we use a set of decentralized UI building blocks. So that actually means that for every step in that user journey, we have different possible UI building blocks that can be used to visualize this journey for the user. I'm talking about UI building blocks, but that can both be a visual component for a web form, but it can also be let's say different types of wordings in a chatbot. So UI building block is not only a visual component, it can also be different types of wordings in a chatbot, for example. As an example, let's say we need your date of birth. In a web form, we can show you a basic input field to get that date of birth with some basic validation. We can also show 3 different input fields for day, month, and year. Or we could show you a full-blown date picker as well. That are different candidates for the same Oslo step. Those candidates are available, and one is selected based on a few elements. First of all, what we use is the language of the user. So yeah, as a side note, this bottom bar is just for demo purposes. So I can easily switch between different parts of the demo. So for example, I can say I'm not Dutch speaking, I'm English speaking. So I want to switch to English and I just reload my page. First of all, of course, the language will change. And as you might have noticed, the style of the input field has also changed because the algorithm believes that this input or this look and feel is better for an English speaking person. Secondly, we use different types of contexts. Context can be anything that is user related. For this demo, we use 3 types of contexts. One is the user vision impaired, yes or no, the device the user is on, and the age or age category a user is in. So if I switch from PC to phone, for example, and I say I'm 18 to 29 years old, and I reload the page again, you will probably see, there you go, again, a slightly different interface. On top of this this setup, of course, you now see the fast look and feel on this page, but as shown in the slides of David, it could be for any city at any government level, so we can easily switch style. Let's say we don't want the fast look and feel, we want the look and feel of Flanders. It's reloaded again, there you go, and we can easily switch styles as well. So that's the generic part, and that is all used to be combined. Combined with the user feedback. That's also what David explained. Based on the behavior of previous users, certain building blocks for certain contexts are rewarded and will be chosen over others based on previous behavior of other users. Now, if we continue by completing this form, these are 2 basic input fields, so I can provide my first name. If I want to continue now, of course, the requirement I showed you in Scratch being there should be exactly 1 first name, 1 last name is of course checked. So I need to complete my last name. What this page is doing now, it is submitting my first name and my last name to the user journey composer. Based on that data, the user journey composer will present us the next available steps. So up until now, this page or this UI generator was not aware of what will be the next step. So that's all done at runtime. So if I complete this field, and yeah, I did make a mistake on purpose, of course. I say I live in Ghent. So we don't only check on whether a field is required or not, the regular expressions that were part of the Scratch interface are also validated here. If I change it and I submit it, there you go. It's successfully submitted. Now this data is sent back to the user journey composer again, and it will present us with the next steps. But I think you get the point. So I wanted to switch to the fast chatbot, which is built in the same way. So also built on different available UI components, being conversations, of course, in this case. Uses the user journey composer as an input, and so on. So let's get started by confirming that I'm ready to start. Again, first question is my name, my first name. I can just answer. Last name. Now, what it does next is I reached my first sub goal. So the chatbot asks me for confirmation. If I confirm, it is again submitted to the user journey composer to be able to present me the next steps. Now, I made a typo in my last name, so I can say no, not everything is correct. I want to change my last name, and the chatbot is able to understand what I meant. So I can just update my last name. I'll be asked for confirmation again. Yes, this time it is correct, and it will ask the user journey composer what is the next step, the next input that is required from this user. And I hope the user journey composer allows me to continue. Okay, let me just reload the page for a minute. So I'm just going to confirm my first steps again. And hopefully, yes, there you go. So now we receive the next steps from the user journey composer. And again, it's asking for my email address. Again, if I make a mistake, you'll see that it is noticed and I get feedback on the fact that I need a valid email address. What we added here on top of what you saw in the forms is actually that based on the regular expressions you add in the Scratch UI, we will at runtime generate a valid example. So the example of Jan Janssens at provider.be is generated based on the regular expression we receive from the Oslo steps through the user journey composer. I can now enter a valid email address and then I can continue again. Now, this chatbot keeps asking me question after question after question, but it does not necessarily mean that every answer I give to a question is actually an answer or an input for that question. So the chatbot is also able, of course, to detect certain other intents. Let's say I need some help. It's, of course, understands that it's not my phone number, but that I want to do something else. Yeah, we didn't implement a complete documentation page, but it is at least showing that it understood what I meant. So I think you get the basic idea of how this is all integrated. Now I wanted to show you one more thing, and that's what happens when I start editing this user journey or this live event in Scratch. So I'm just going to give you a basic example. Let's say instead of first name and last name, I'm only going to ask for the last name. And let's say that, there you go, phone number and mobile phone number, it's not required anymore. We remove that since if we have an email address, that is enough. This is automatically saved. What I can do now is in the forums editor, I say I want to load the latest version of Scratch and I want to start over again. There you go. And now you see it immediately shows me the form again, but the first name is missing since I removed it from the Scratch interface. So I just need to provide my last name and I can continue. There you go. On this page, if you remember from a few minutes ago, there were 4 input fields, so phone number, mobile phone number, email address, and address. I actually removed the fact that the phone number and mobile phone number are mandatory. But what the user journey composer did is it decided that for me, it's not relevant to ask it anymore. So the user journey actually, what you see here is that the user journey tries to optimize the journey and it just skips every non-mandatory question because it would be an additional step and an additional hassle to fulfill it. And that was actually what I wanted to show you as the most important parts of a demonstrator. I would like to give the word to Tim now, who will be showing how we went from this to an actual use case for Bosa. So Tim, go ahead.
Hi, good morning, everyone. Thank you, Sander. First of all, let me try to share my screen. So I hope this is coming through well. So first of all, let me present myself. I'm Tim. I'm working for Internet Architects. I haven't been actively engaged in the FAST project, but I am the account lead for the service design framework contract that we have for BOSA, digital transformation, so at the federal government level. And there we have done a technical proof of concept around a concept that is related to the European Single Digital Gateway Directive, for which BOSA Digital Transformation is the National Technical Coordinator. And we have used FAST, so the FAST APIs, as one of the technical building blocks to build our proof of concept. So that's what I wanted to go through with you today. So I'm not going to explain the context in detail. I'm actually reusing the presentation that we used to close off and demonstrate the POC. So that's the different stakeholders than the people here in the meeting. But the challenge is more or less the same. That's what Raf already showed you. Fragmented user experiences with the information scattered around different websites, all of which have no integration amongst each other, let alone cross-linking. So that results in a lot of duplicate information that you need to provide as a user, because one website doesn't know about what you've already accomplished on a different one. For instance, maybe they could even require you to perform redundant steps, or to go through a process again that you've already gone through the first time. The third problem is, of course, not every step in all of those complex things that you need to handle with government authorities are digital yet. So for some of the steps, those still require you to physically present yourself at the counter, so at the desk somewhere. So that's not ideal, of course, because then you're dependent on opening hours and on the ability to physically present yourself, of course, and that's not so handy if you think in the European context. For people that are abroad, that's not so easy to do. And of course, because there's a lack of an entry gateway, of course, Google is de facto used as a gateway, but Google is not the government search engine, it's a public search engine. Where private information sources compete with public information sources. And so the user is all the time making the assessment of whether he is or is not on a public channel. So that could be a trust level even. So it's a really complicated environment. And what we want, of course, is we want to have everything in one place. So that's often called the no wrong door principle. So wherever I present myself, I should be able to apply or have the full application form for the entire procedure. It should be once only. So if I previously provided information to a government instance, you shouldn't ask me again. Of course, it should be digital first, so available 24/7, and of course on the platform, the technical platform of my choice, whether that be in a web browser or in a digital app. Of course, what I want is an easy-to-use experience, so that I can have trust and confidence in that my application is actually being handled. So I want at least to have a view on the status and the progress and what is still left to do. So that is the basic challenge from which we started, and the challenge is actually almost exactly like that is formulated in the Single Digital Gateway Directive. So poor understanding of rules when you're dealing with another member state. You don't see all the steps required to carry out ordinary procedures. Information is scattered all over the place with no guarantee of quality or reliability. What does a Single Digital Gateway propose to all of its member states is, look here, we have defined 7 live events, and we've coupled a total of 21 common procedures to all of those live events. And so we are asking all of our member states to make those 21 procedures digitally available and usable to all of the EU members. And that's both in terms of providing the necessary information, so what's required for you as a citizen to perform that procedure. Also the transactional part, of course, so the actual interaction And then if you need help or assistance, it should also be clear who to contact. So that is, especially in a complicated country like Belgium, it's quite a challenge, but it's in legislation now, so we have to comply by 2023. So, and like I said, Fotbosa Digital Transformation is the technical coordinator. So they have to see that all the technical building blocks and parts are in order by the deadlines that are listed in the directive. So, and their strategy is okay. First and foremost, let's not build something specific for other member state citizens next to what we have for our own national citizens. So whatever we build or whatever we have to solve to be compliant with the legislation, it should be a structural solution. So we're not going to build extra silos just to make the deadline. We're going to make it work for our own citizens first, so that all these procedures can be digitally performed in an easy-to-use way. And then we're going to see whatever we need to do to also make those digital procedures available cross-border. So and our approach was to map the as-is customer journeys for all of those procedures, to see what are the different administrations that you have to contact, what are the different steps that you need to do, what is already available, where are the gaps, and then specifically from the Fotbosa perspective is, are there any recurring patterns that we can detect across those journeys, because those would be prime candidates, because the mission for Fotbosa is to be a generic service provider to other administrations. So that would be the prime opportunities to build common building blocks that can be reused by different instances, so that they don't need to build them all by themselves every time again. So we identified a couple of building blocks that way. Not all of them were retained, but some of them are pretty abstract concepts. So to get them going and to explain exactly what the solution could be, we decided to build a working proof of concept around the building block number 5, which was identified as we should standardize all those procedures. They're built differently. Every organization does it differently. We need to standardize it and make them interoperable, so that it becomes predictable, it becomes reusable, and then ultimately more user-friendly. But of course, a proof of concept is pretty limited in terms of budgets. Forcefully, we need to look at, okay, what are the building blocks that we already have today that are already in place? So can we reuse those to build what we want to achieve here? And then see what is still missing to get to the vision and the desired user experience. And that would then be the next steps to work on. So we set out to build a proof of concept. The philosophy there was, okay, if a citizen engages to fulfill a complex procedure that is scattered around, or for which the responsibility lies with different administrations, that it should we're not going to build a centralized environment, because that's not going to work especially in Belgium. We're going to leave the ownership with the administrations that currently have it. So backend, the case management and all of that should stay decentralized and with the proper administration. But with the technology of today, we can actually try to read whatever they propose in terms of procedures and bring it all together in one centralized front end. So the connector between the two is actually interoperability or standard application programming interfaces. Okay, we needed to select the scope, and okay, because of course we were well aware of the work that was happening in the FAST project, we chose the moving journey. And like Rafa and David said, it's a nice journey because it's complex enough. It has enough parties involved to be an exciting challenge. And then we looked at, okay, what are building blocks that we could use. So what do we need is actually, well, ultimately, what we need is a standard for describing procedures, so we can puzzle them together. And there you see that, okay, at the Flanders regional level, you had also steps that was being developed. But at the European level, you also have CPSV AP, which serves to describe procedures at a meta level. Then we need a way to, if we have the procedure model, we need a way to read it out and visualize it into a journey. Because that's something I need to mention is in the timeline, we actually were a precursor to the demonstrator that Sander just showed you. Because at the time we started, there wasn't any Scratch interface yet or any working UI composer. So what we did is actually we just took the moving journey as it was modeled in also the steps and the API that was already provided on top. And we just took that API and we did all the visualization ourselves. But I think that also proves the modularity of the concept. And then, we need, of course, we need to know who the citizen is. So we have a building block for that at Foncosa. It's called the Federal Authentication Service. We can use that. And we need a way to, if we know who we're dealing with, we need a way to retrieve the data that we already know about that person, so that he doesn't need to provide it again. And for that, we used the Federal Service Bus, which is actually a connector to all the different authentic sources that exist at the different public administration levels. So, and then we stitched it all together. So we had existing building blocks for modeling, we had building blocks for authentication, and we had building blocks for retrieving known data. And that's what we started with. So when we set out to construct a working demo, of course, I'm going to give you an actual demo in a minute. Or keep in mind that because we're in a proof of concept here, so you have constrained time, constrained budget. So we took some shortcuts and some corners there, but it just serves to prove the essential parts, which is okay with these building blocks. We can build something really nice, really valuable for end users and also for European citizens. So what did we build? So the first screen you see is a hypothetical gateway where you can list all available procedures that have been modeled. The titles and the descriptions you see here are fueled by the CPSVAP specification. So it's not also steps yet, so it's just a way to describe procedure metadata. The citizen login, that's handled by the Federal Authentication Service. So here again you have so this is the detail screen for a procedure where the title and the description is used again from CPSVAP. But then you see a static view of the Oslo steps model here with steps and per step what is the information that's required. So not in an interactive form yet, it's just a way to provide information about the procedure, because that is something that is specifically required by single digital gateway as well. So but just for that step information, we can use also the steps as well. But then you log in as a user. We ask for your consent because we're going to retrieve data from you. You log in through the Federal Authentication Service. I suppose this is an interface that you are familiar with. We configure this to a level of assurance that's high enough to be confident that the citizen is exactly who he is. So we choose the high level, which leaves us with either you log in with an EID and a card reader, you log in through It's Me, that's the application, the private initiative, or you log in with EIDAS, which is the European authenticator service, where all the member states can notify the digital keys that they think are compliant with SDG. And then this allows you, for instance, as a Swedish citizen or a Polish citizen, to log in with a Swedish or a Polish digital key into Belgian services. And then once you're logged in, we can present you with the interactive version of the procedure model. And so that's more or less what Sander just showed you, but just in a less sophisticated way because the project was not that far along at the time. So you see the steps on the left-hand side, and then per step the data on the right-hand side. This is built up all through Oslo steps, but then the information that is retrieved is actually done through the Federal Service Bus, which, as I explained, connects to the authentic sources. For instance, the National Register, a list of addresses, so all of those things. So it tries to retrieve as much as possible. And then, yeah, this is Sandra also showed you that just to convince the people that we show this presentation that we are not trying to build a single central federal gateway, but that we're aiming for a similar user interface at point of first contact. We also building a style sheet switcher just to show you that you know, the interface actually doesn't matter. It's where the user lands that we can compose the entire journey for him in a personalized way. So, and then of course, once you've gone on through all the steps, a piece of evidence like a certification or an attestation that you might have to present as a cross-border citizen to a local administration in your home country. So that, for instance, that piece of evidence could be sent to your e-box where you can download it and send it. But that's just a little detail for the specific proof of concept. And that was done later on because we had done all that work for the web part of the POC. We used just a couple of days to, you know, reuse that work and translate it to a native mobile application, just to prove that, you know, everything we do here is reusable, and you know, you can get it working with a really limited amount of effort. And so just to convince everyone about the need and the value of standards and APIs, basically. If you have an API, just give it to someone and they can build really nice things with it. So, and now I'm going to provide you with the actual working demo. So I'm going to quit the actual presentation and show you the browser interface. So you've seen this, this will be the hypothetical gateway. I find the procedure that I'm looking for. I want to move from to Belgium from an EU member state. View this procedure. Here you see, okay, if you want to do this procedure, these are all the data that you need to provide. And then you say, okay, I'm going to engage with this procedure. I'm going to use the Federal Authentication Service here. You see that you can choose an appropriate digital key here. I'm going to choose It's Me here. Because it's the easiest one to demonstrate in a live demo. I'm going to provide my phone number. This. And then I'm going to authenticate in the app. Now I'm logged in, and then when I go to the first step, you can see this is my name, this is my national registry number, this is my place of birth, this is my actual address. And you can also see the flaws because this interface is not, we haven't hard-coded the interface, it's generated dynamically from the FAST API. So any little flaw that was in there in the model, like some weird language here and there, it's just in there as it is. So that's just, but it's also part of the proof of work, of course. And then when you get to, for instance, get your address changed, that is one of the steps. I can see here all of my family members, 3 children, they're all in there, and I can who's going to move with me as well. So voila, that's just a quick way to show you the actual working demo. And so just to remind you, this is to demonstrate that by puzzling together 4 different APIs, we can construct an exciting user interface that's really helpful to citizens with a minimal amount of effort. And that was the entire intention behind this proof of concept. So thank you for watching, and we'll switch back, I suppose, to Sander.
No, David will end this session and talk about valorization.
Okay.
Okay. I'll share my screen again. I think that'll work. Do you see my screen? I don't see you, so could somebody please say yes or no? Thank you.
Yes.
There's a problem here. Okay, now I see you again. Okay, so what did we learn in room 2, according to me? First of all, we have showed you that what we had in our dream is feasible. So we created a demonstrator that brings that dream into reality. I also think we've made sure that with the demonstrator of Tim, that we prove that it is also viable. So there are specific use cases in the government that needs the help of technologies such as FAST to solve their problems, particularly in the single digital gateway area, where different governments need to bring their processes together to come up with live events that is suitable for many different target audiences. And thirdly, we also have had numerous discussions and meetings already with communes, the Flemish government, the federal government, and so forth. And what we see is that there is a huge interest in the technology that we're currently creating. So what's next then? First of all, we are currently ready to implement the added value of this FAST technology in reality. We have building blocks now that can be used not only, as Tim showed, to use it in a proof of concept environment, but also to integrate it in projects. Doesn't mean that we already have a fully fledged, finalized product. That's not the case. That's what we're currently exploring, how we can move from the current great building blocks towards a technology that is productized. And probably we will go into 2 steps. First of all, we'll create an open source product, and then afterwards we will put commercial products on top. That's the current idea. We want to go for beta clients, the first beta clients in 2021, and start building an open source offering this year. And then as of 2022, we will start working on our commercial components on top of the open source offering. As of 2023, then these commercial offerings can then be fully and internationally exploited. That's the basic idea of what the next steps are. So that's about it. That's where we are now. And yeah, that's also the end of our presentation. If there are any questions, please yeah, ask them now.
I got notified that the other track is running late, which means that the closing will be at 11:55. So we have about 10 minutes left for questions.
Yep.
Before. Yeah, go ahead, David.
Yeah, maybe I also asked, but I didn't get the answer yet, whether we can otherwise ask Hamza to talk already now, because otherwise, the event will run in until 12:15. I didn't know. Any questions?
Maybe just for me, just to chime in on the viability part. So I can confirm that from my own experience. So I've done demos of the proof of concept at the federal level with different stakeholders that are involved with getting compliant with SDG by 2023. And I also did demo at the European level where they're thinking about once only as a principle. And everyone you show this is extremely impressed. So I think the problem solution fit here is pretty clear. And even with the Scratch interface that you've developed in the meantime, I think it's really impressive. You should show it to the people involved because they're all quite excited to get working.